So let's talk about constructors. So I'm going to show you some boring examples here. And they're not boring. We should know already we have the object creation. So here's this class, and it's going to be called body. Why do they call it body? It could be pencil, or it could be pen, or one of those other examples I gave you yesterday. We have some data members we put in the class. We have some member functions in the class. And when we make a new instance of this object in main, we go body space sun. We define a variable sun to refer to the body object. And it's going to be equal to new body. And we have an opening and closing. I purposely put a space in here so you can see it's empty. This is not using a constructor. Instead, this is making a new instance of this. It's like you can do the same thing and say integer I, or my int, whatever, is equal to new int. You can do that if you want. Basically, the new allocates, and this is the type, and then we have this format here. So it creates a new body object. The object is created with the new method. This is a new method, believe it or not. Or, I don't know, just some of the vocabulary you're just going to need to get used to after a few times. The runtime system will allocate enough memory to store the new object. If no memory is available, automatic garbage collection will go through. Occasionally you might get this out of memory error that might occur. Very rare, but occasionally you will. There's no need to do a delete, as I mentioned yesterday. Other languages, you may have seen the word delete that goes along with new. New, delete, new, delete. Don't have to do that for this class, or for this language. So I mentioned the word constructor, so that's the theme for this morning. Constructors are used to automatically initialize the data in the class when you make the new instance of the object. This is technically running the default constructor because it doesn't have any arguments in it. It's empty. We can make more than one of those things, so it takes on any number of arguments. So the constructor is a way to initialize the object before the reference of the object is returned by new. Add stuff in there, automates it, makes it run faster. Has the same name as the class. So it's the same name as the class. It can't be run by you. It gets run automatically by new. So the runtime environment runs it for you. You can never call a constructor after the object has already been created. That's where the set and the gets come into place. Can have as many as you want, and as long as they take on different parameter sets. Can have as any of the same accessor methods as well, the public, the private, protected, and we'll look at that again today with some source code. And it's similar to methods. So a class can have multiple constructors as long as they have different parameter lists. Constructors don't have a return type. We'll write some constructors and you'll kind of sort of see how they're a little bit different. Constructors have no arguments. The ones that, the constructor that does not have any arguments is referred to as the default constructor. It's empty, doesn't take on any parameters. If no constructor is provided explicitly, the programming on the line, the default one is done. In the default one, you can set anything that you want. So here's a class example, and here's one constructor, and here's two constructors, which is interesting. So, and then I'm going to talk about this and super in a few minutes as well. So we have class body. Don't worry about the data if you're still having problems with data and class and instance level stuff and static. Don't worry about that yet. This is what to look at. So this is the default constructor, has the same name as the class, but it doesn't have a return type. So we didn't put in here integer or void or anything. So some people are tempted to put void in here because it doesn't really return anything, but doesn't have to. So it doesn't have a return type either. And what we did here is we set ID to equal next ID. So we initialized a piece of data, and we set it to next ID. So when we make a new instance of this, this value will be populated automatically. And then here we have a string body name, comma, body object orbits around, and we have two strings. Just imagine this as being two parameters, and you're separated by a comma, that are being passed to this when we make the new instance. And then we have a keyword this in here. I'm going to go through this in a few minutes. And then in here we have name is equal to body name, orbits is equal to orbits around. So we take the parameters and we assign those parameters to the variables that are in here. And then we assume that the nobody constructor before is used. So when we run this one here, body sun is equal to new body. Sun is now ID is equal to 0. The name is empty and the orbits is null because it's not being assigned. We're only assigning the ID. And next ID happens to be equal to 0 because we set it to 0. And then we assume that nobody constructor is used here, and then we basically run this method. So here's the difference. If you create what we've seen so far and we looked at yesterday with those pencils, P1 is equal to new pencil, when we run that method, only what happens in here will get executed, which is the default constructor. If we run this one over here, we know we're going to run this one because we're going to send it 2 strings. As an example, null was a replacement for a string. And then down on the bottom, we can set new body earth, sun, which is the slide is kind of overlapped here a little bit. But this is it's basically 2. This is the constructor here. We're sending it 2 parameters, and the 2 parameters are being populated, and this constructor is firing. So now we have the name is equal to, and I'll show you this live in a few minutes, so you'll see how the source code is written. Then we have this interesting word, this in here. So this. Inside of the constructor, you can use this to invoke another constructor in the same class. It says, this constructor here is going to set name, this one is going to set name and orbs. This is going to come up and say, okay, let's set the ID too. So we'll run the default constructor. And let's use passive information in here. Because this is basically a way of running a constructor inside of a class. So this guy's also going to run this guy. What does that have you do? Well, you don't have to take this, cut, copy, paste it, put it in here, and you don't have to duplicate it. You just say this, which means run this constructor. And this constructor, here's the default constructor it's going to run because there's not any parameters in it. Super shortcut way of doing it. If this class was being inherited from another class, which we're going to see later today, then this word here would be super. So super means the class above it, and it's the same format. So in super, you can just run some stuff in here. And what are you going to run in here? Well, if we had a parameter in super that looked like this, excuse me, if we had a parameter list in a constructor that looked like this, then we would put in here body name, whatever it was, comma, null, or another string or something. No, this is a body object, by the way. So it's sending an object to this object. So this is inside. So this invokes another constructor in the same class. This is an explicit constructor invocation. It must be the first statement in the constructor body if it's going to exist. You can't put this at the end of the code. It always is the first statement. Super as well. It's always on the first statement. It just says super is just in the inherited class, run this constructor. In this class, run that constructor. Optional. You can create it without using this or super. But you're going to do things longer. So you're automating it by reusing it, so you don't have to put this line of code in here, which would be the equivalent. So take this out of here and put this down here where this is, and it would be the equivalent functionality. That's really all the steps you're saving, but usually this is a little bit longer. So it's not just a cut and paste of one line. It's normally a lot of code that you're reusing over and over again. It kind of gets a little tedious. So this can also be used as a reference for the current object. This dot ID, this dot name, this dot orbs or something can be used. It cannot be used as a static method because static is class level. So inside of a static method, you're creating something that's going to be used by all instances of the class. And I'm going to show you an example today of static methods and instance methods when we go through it. Today's about putting the pieces together. But you'll see you can't use this because there's no this. This doesn't exist. So just think of this as this current object. And here's an example here. This name, this orbs. If you leave this off, it's assumed to be this. It's inside of the class, right? What would it be? Well, you could go super.name dot as well. Would mean it wouldn't be this one's, but it's the other object we inherited from. That would be super. So people who use this use super a lot. That's why you see source code examples and you'll see them in sets, because you're going to try to be specific. It's this object, or is it that object over there? So this dot name, this dot orbs, and then we have this body list dot add this, which is this object. So think of this as this current object that you're dealing with. It's yourself, this. So some languages use the word self. Self is a C++ term, actually, by the way. Self means this. Why Java didn't use self, I don't know. Because C++ uses super, and Java uses super. But self is now called this. Okay, well this, self. So I can learn 2 languages in one day. Other initialization methods. This is not encouraged, but you can create what's called an initialization block, not a constructor. So what you're doing is you're taking and you're putting a block of code. This is where these little boxes are. There's no code in here, but you're putting a box of code in here to run something. And this is without an initialization block, and this is with an initialization block. And here you have a name on it. It's called body. It's kind of underneath the box because the box is too big. And over here, there's no box name. There's no name at all. It's just an opening bracket and a closing bracket. Problem with this is you can't use this in super to run it. It's outside of the constructor concept. You put it in there, anything you put in here is going to be initialized when the instance gets created, but then it's only going to run at that time. You don't have very much control over it. So those people who don't like constructors, which is kind of rare, you might see some sample code, legacy code, people who are afraid to use constructors. They'll make a little initialization boxes, and basically they put line of code in here without giving it a method outside of a method call. Anything outside of a method call is referred to as an initialization block. Only gets run when the object gets created. You can't run it after the object gets created, and you can't call anything from it either. So it's kind of stuck. But it does instantiate, it does run on when the object is instantiated. So it does run automatically. Static initialization blocks, don't worry about that. If you put the keyword static, in fact, here's some code. This is what's referred to as the initialization block. There's no method name to it. The keyword static is going to do the opposite. So instead of when the instance, but when the class is used instead of the instances, the static initialization block is going to work. Hardly ever used either. So, in fact, I don't know why I'm even showing this to you. You're never going to use it. So that's why I'm going to skip by it a little bit. But those people who are familiar with it would appreciate knowing that you don't have to use a constructor. But 99.9% of the time, you're going to want to use a constructor. And at this level of programming that you're doing, you're going to use a constructor. So, packages. Did you have a question? It's not a constructor. It's an initialization block. You're never going to make a constructor static. Yeah, there's no need to. You're never going to use an initialization block either. Why not just put it in the constructor? Constructors can be called. We can use this to call one. We can use super. We can go back and forth. It's accessible. When you put it in an initialization block, it means you're taking it out of the system. You're just going to load it right up there next to your data members. And when the instance gets created, it's going to run automatically. But there's no way of controlling. You cannot not run it. You can't stop it from running. And then once it runs, you have to deal with the consequences. So remember in the old days, people used to declare and initialize variables. You say integer I, integer A. We did this yesterday. Actually, I wrote an initialization block yesterday because I went F is equal to something, A is equal to something, B is equal to something, and I wrote all that code. I initialized all those variables right up there at the top of the code. It did not use a constructor. That's called an initialization block. To be fancy, you could put an opening and closing bracket around it, but as we saw yesterday, we didn't even need the opening and closing bracket. So if you still have create pencil, actually, maybe I still have it saved in here. I believe it was inside of pencil. This is going to open up an Xcode, I believe. Yes, it is. I just want to look at the code. Here we go. This is a classic. Maybe I can make this bigger. This is what's called No, I didn't do that. I didn't initialize it up here. If I take and initialize this stuff up here without using a constructor, and this does not have a constructor in it, but if I did this stuff here and I put it up here, that would be an initialization block. And technically I'd want to, put some forwarding and closing brackets in there, and then I call it an initialization block. Doesn't serve any purpose outside of being able to initialize data. It doesn't work as a constructor, it doesn't act like a constructor. It confuses everybody when they look at your code. They go, why did you do it that way? So. Packages, unless we have other questions. Okay. Classes can be grouped in a collection called a package, as we've seen before. Java's standard library consists of a hierarchy of packages. We saw this with the source code, but we didn't look at the kind of formalization of the terminology here. Such as Java Lang and Java Util are two different packages that come with this here. This is the API that you downloaded. This is what we downloaded yesterday morning. Two main reasons to use packages. It guarantees the uniqueness of the class name. You're not supposed to reuse the same name of a class in the same package. So you can only have one create pencil, one pencil, and you put it in different packages and you have different builds of it, or different versions of it. Classes with the same name can be encapsulated in different packages. And traditionally, a package name reversed is the company's internet domain name, as I mentioned before. So in this class, I'm going to use edu.itu.examples or something like that, or .hello world or something. So kind of follows in the reverse, and that's a Unix thing again. So it comes from Unix. Class importation. So we saw this actually. Well, we're going to see it today. Importing stuff. So there's two ways of accessing public classes inside of another package. So explicitly give it the full package name, and here's an example here where we have javautil.date. Right before we say date space today. So this is a implementation. Here, I'll go out here. I'll show it to you this way. Let's see if I can get. Let me see if I can get the text bigger here. View, text display, show fonts. I find that the bigger is the better here. 18. Let's put it on 24. So we can initialize, let's say for example we have pencil. We did this pencil.p1. Pencil p1 is equal to new pencil. This is what we did yesterday. And this was a pencil that we created. What if there's a date we want to use, and the date's inside of one of the included packages? We can go date.d1 or something like that equals new date. We instantiate objects of all types the same way. If we have a pencil that takes on the color and the size, we can go red, comma, 2 or 3 or something. This is running a different constructor, as we just saw in the previous example. And this here is going to initiate the pencil with that one. We can also do this as well, because just because we have multiple constructors doesn't mean we have to run one or the other with all instances. We can pick and choose which one we want to use. So we can also do that. So this is basically saying, here we have this Java util. And so I was hoping I was going to cut that. I can't cut that. Okay, I'll just do this here. If we at the top of the code, here's the top of the code, we import Java, lowercase java.util. If I put this line of code at the top, and this is going to tell me it's not spelled correctly. But don't worry about the syntax right now. If I use this import and I put it up here, then I can do this no problem. If I leave this out, take this off the top of my code, imagine I'm writing main here, and I go down here, I can do this instead. I can go java.util.date. It's kind of like IO string and C in and C out and how you preface it. If I don't want to do this all the time, then I put it and import it at the top. And if I'm doing it here, I have to do it here, I have to go here, because the date's not recognized. Java.util.date. Because I didn't import it at the top. And I'll leave this word import up here. Okay, so Import package by using the import statements. And you put this on the top, import java.util.date. And this is the proper syntax for it, so I'll copy this up here so we can kind of see it. Import java.util.date. So, and the asterisk is going to give us, and I'll show you that in a few minutes. Here's down here. Import all the public classes from the util package. Well, then we use an asterisk. So the difference between this and this is the same thing that you get in DOS when you do a star dot star. Give me everything. This one here is going to be util dot asterisk. This is everything, and this is just the date. Yes?
So when we are importing just specific library date, or we are using asterisk, so what's the difference in terms of performance? Will there be?
In terms of performance, there's absolutely no difference. It does the same thing for us. But we have a little thing that might be interesting here. What if we did this? And I want to use the SQL date. And there's a date inside a util. I have two dates. But if I import just this date out of SQL, it's going to I got this date, and I see the second, it's not going to import the second. It's going to go, oh, util, skip the date, we got the date out of SQL. So it'll take the date and it won't repeat it, because then you're going to end up with a problem with multiple includes or multiple, how many dates you got here? Well, you can specify out here. I could just have done the same thing. In fact, I could do this if I wanted to. Java.sql.date d2 is equal to new java.sql.date. But this is a lot of typing. It's easier to come up here. This is why you see only one thing. I want the util dates. Excuse me, I want the SQL dates. And then I want everything else out of util.
So, do you mean to say, like, if date is selected, the first and the second line will be omitted for the date specific?
Yeah, it's going to find it.
If I reverse, swap the lines, what happens? Like, if I do the util date first?
It actually, believe it or not, the same thing's going to happen. It'll find the date and go, this date. It'll redefine it as the date. If it's a single and not an asterisk, it does, it finds what's here now. It's kind of like how it searches for libraries. It looks in the current directory. In fact, if you load all of your class files in the current directory, it will always run just fine. If not, it has to go through the class path, and it'll check sequentially until it finds what it needs. And then when it finds it, it'll add it in. So I actually have the two scenarios in here, and it might make some more sense. So I'll continue with the example, and you probably won't have your question. It'll probably answer your question in a few seconds here. So for the class importation ones we just saw a few minutes ago, you import the import statement goes at the top of the code, and just below the package statement, if you have one, and the package would be up here. So if you have a package statement. Packages, let's not worry about packages. Packages basically puts everything all into one package, and then you add stuff to packages. So below the package, no need to give the package name anymore. Instead, you just go in here to import a single class from the util, and I'm going to show you examples of using each one of them. Java.util.date. And so now we can go date today is equal to new date. And then to import all the public classes, use the asterisk. So it's used to import classes at the current package level. It is not to import classes for sub-packages, just at the current package level, which means if I have something in here, util.something else, or back here, if there was something before it, no. It's just at the current package level. So everything that's in the util package level is going to be included. So here's an example of import to JavaX swing, and then we have menu event, which is a swing component that's being used, and then C. And then when you compile it, it's going to say, can't find the symbol class menu event located in sample class. And it's going to complain here because menu event is in a class package called swing event, and we didn't include that. We just included swing. So it didn't go the next level. So think of it like a hierarchy, and you're picking the hierarchy or the directory, and you're saying everything in that directory. Because this is really a directory, by the way. But instead of the dots, we have, you know, forward slashes or backslashes in file systems. The dot's equivalent to that. So we didn't include event. So we're going to get an error like this. This is going to happen to you when you first start writing programs, because you're going to go, well, what package level do I need to include? And that might end up being a problem. So what if you have a name conflict? And here's the answer to your question. So here's our name conflict, where we have imports, and what we're going to do is we're going to take them both in. And the same problem occurs if you do it this way as well. Eventually we're going to have a name conflict because we have them both in there. So even if we did this, we could say, if we did this, all we're doing is we're taking date in, which we're not getting anything else out of SQL. So it's kind of equivalent to doing that, because there's a date inside a util. So now we have date today is going to be equal to new date, or we're going to get an error. Which one do you want? Do you want the util.date, or do you want the SQL.date? I don't know. So if you only need to refer to one of them, they import that class explicitly this way. This one's going to be used instead of that one. So if you have an explicit, it overrides the other one. It doesn't matter which order you have it in. So this is an example of reversed of what I did over here. So this one I put the specific one here. The same thing happens in both cases. It doesn't matter what order, to answer your question. But you can also explicitly use both. So you can go here, for example, java.sql.date, java.util.date. And they're both in there, which is kind of weird. So the one that is in there explicitly stated will go by default. The other one is still there. You just have to say which one you want.
So in this case, we are actually explicitly specifying that these two variables are going to use the date from SQL.
Correct. This one.
Other variables can be actually taken from the whatever we import.
Yeah, this one's going to come from util date, because I didn't specify which one. So you think of this kind of like specifying the default. If you don't explicitly specify which one you want, it's going to implicitly apply the default that you've put here, but it's not really called a default. It's just kind of like what's going on. We still have access to both, however, and so we can go down here and we can say, here's both. Here, actually, we've put both of them in. We can have both of them in there, no problem. But if we do that, we have to specify which one we want. So here's the problem. You don't know which one is in which one. You don't know there's a date inside SQL, and then you get this funny error message. And then you end up doing this, because the help system is going to have you specify which one you want. So another source of kind of, not really problems, but it's kind of confusion to some people. So for the programs that you're going to be writing in the beginning, you might run into the problem, who knows, but probably not. It's only when you start using these asterisks all the time, you go, everything in here, and everything in here, everything in here, you start including multiples. You get this in Android a lot, actually. And then you see in the code, people just do this automatically. Android.google.map, Android.google. Because the Google libraries, you have map APIs for different platforms. Well, you used to, now it got converged, but you have SQL dates, you have utility dates, and you have all the packages that are available in Java that are not Android related, but they're true core Java is available as well. And add those in with all of the Android APIs, and you got multiple dates all over the place, and multiple this, multiple that, multiple maps, APIs, multiple list views, and context views, and everything is all mixed up.
So what I'm checking when we're importing is like java.lang.map. So Java is a directory, lang is another subdirectory, and map is going to be a class file.
Yep.
So
that's a specific, this is a different example, but this is a specific class, you're right.
So do you just say that we can create our own class file and import it into
Oh yeah, you can specify this one. This is what this is doing. So instead of just taking the directory, inside of lang, inside of Java, we have math. And then over here, we're going to use math as the object. And inside of the object, we can use this method here, square roots or something, or whatever it is. And then it's going to give us an error here. It's going to say, can't find the symbol, method square root. So because it's a static method, so you need to refer to a class name. So this is where you're going to see math dot, I don't know if I have it here, I don't. You're going to see math, in order to fix this problem, you have to put the keyword math in here. Oops, up here. This says math. So sometimes you'll see this. This is an error that's going to occur because we included the class, but we didn't make an instance of it. And we have class level instances, methods that we're running, which is kind of like why I wanted to show you the difference between class level and instance level. This is all static stuff that was defined by the compiler. So if we put capital M, and remember this is always capital, math dot, then it works just fine. And we're running this as a class level variable, and excuse me, class level method from the math class, which kind of breaks the rules of instances. So don't worry about this, but you'll run into the situation when, and hopefully maybe further down the road after you've been doing it for a while, you go, why is that? It's because it's a class level. You're accessing it through a class and not an instance. And believe it or not, even experienced programmers have a tendency to not even understand what they're doing. They just do it because that's how it works. And then they go, oh, further down the road, they go, oh, it's not an instance method, it's a class method. That's why it works this way. We'll see it today actually implemented in our own class. Good questions. Any other questions before we continue? Yes? Oh, I love your questions, yeah?
Yes. Yeah. So import, right?
Yes.
So it means like we have Java installed in our system.
Mm-hmm.
And we have all these class files stored in some organized structure.
Correct.
And when we are running a program out of that pool, we are actually picking a couple of classes which are actually specific to our
Correct.
program. So whenever we are running our program, we are importing a couple of them which actually need it.
Uh-huh.
And you say that there is no performance issue. So why do we have to explicitly import anything?
Good question. It's kind of like, why do you have to use includes in C++? It's just, I don't know why. There's absolutely, it makes no rhyme or reason to it, why you have to import and why you have to include. Other than the fact that it would take too long to compile something. So okay, so his question was, if it's not going to use it, why import it, and why do we not get any performance problems? Because here's what happens. The compiler is going to parse the source code. It's going to come down here, and if we had written this correctly and it says math.square root, it's going to go, math? Where's that? It comes up here and it starts looking through your imports. So the compilation will run faster if you put this in here versus an asterisk in here. Just give me all Java lang, because then it's got to go through the Java lang area of the import and say, where is this math? Where is it? Where is it? Finds it. It includes the code that's needed to make that method work. Gets rid of everything else. It's kind of like comments. Comments are always removed. So comments don't really affect your performance either. So you could put like everything in the entire Java language out here. If it's not being used in your code, it's not getting compiled with your code. The performance of the running of your program isn't going to be changed. So I guess we have to define what we mean by performance. When I hear performance, I'm always thinking about the runtime of the program. And the performance of that program is not going to be affected by any comments I put in the code or any libraries that I'm including that I'm not using. The compilation will run, well, it depends. If you are using all that stuff in the code and it has to go back out and look for it, the more stuff you have out here that you're not using, the slower the compilation, but are you going to notice a difference? Probably not. Compilers run pretty fast these days. So you may not even notice a difference. The compiler creates the class file. Once that class file is created, it can't change. It's binary. It's kind of fixed. It's not in a full executable file. It needs the runtime environment to operate, but it will essentially act as an executable for the most part, for all intents and purposes. And then if you want to change it, you have to recompile it. And when you recompile it, the compiling time is depending upon how many libraries you put in there. If it has to find something. If you only did this, it's going to be real quick. But real quick versus slow, you're a matter of seconds. It's not necessarily a long amount of time. Any other questions? I hear a lot of people talking in the back there. You guys have questions? Okay. At least I don't have to tell anyone to get off the phone in the middle of my lecture. That's amazing. Static importation. All right, so here we have Java SE 5.0. Well, you know what? That's an old version. I believe we're on like update 7 or something at this point. It can also be applied on static fields and methods, not just classes. This is what's called static importation, by the way, because we are importing a static class that's going to be used. We're going to have static methods that come out of it. So importing all static methods and methods for a math class here. We have import static java.lang. Earlier versions worked a little different. All versions before 5.0 doesn't have this feature, but now you don't have to worry about it. Everything now does. Why do you have to keep that in mind? Well, because maybe you're working on some legacy code. We're not assuming that you're going to just come out and write new programs. You get hired as a Java developer, and where's this code? It's from version 1. Oh my God, and you try to do something. Keep in mind static importation is something new that was added to it, and that you might have some odd behavior occurring. And a lot of people don't convert old code to new compilers because the code works. Why mess it up by changing the version of the compiler? So you'll find that legacy code is always compiled with legacy compilers, so it all works correctly, which is, why people hold on to old compilers and old systems and old operating systems, so you can continue to test and develop without having to worry about modern changes. Encapsulating classes inside of a package. So you add a class into a package. There's 2 steps for it. So we're going to talk about the package concept for a second. So you add a class, there's 2 steps. You put the name of the package at the top of the source code file. So here we have package. So this is my source code file. I'm going to call this package ITU stuff. There we go. There's my package. And then, okay, I can go, edu.itu stuff. All right, there we go. And you'll see in the Android and also in the Java default projects in Eclipse, it organizes it in the package so you can physically see it. And if you don't specify a package, it calls it default. We'll see that today. We'll take a look at it. But actually all you do, and you put here like this could be our public class employee or pencil or whatever we have. And then we put the files in a package into the subdirectory which matches the full package name. Well, it's organized for us automatically through the Eclipse project. So when we go out to the workspace directory and we open it up, we see SRS that's inside of the other package. So it's organized for us completely. If you're doing it without Eclipse, in the old days you have to do it yourself, which means you save it in this directory hierarchy as well. So you store the file. In this particular case, would be stored in some path, com, host, and now you see the differences here with the backslashes. So the directory that I would put this into, on my computer, everything's in users, vhacker, edu, itu stuff. Oops, if I spelled it correctly. And then in here, I'd put all the files. That's the package. So don't be confused about package. I don't use packages, I use default because I'm sloppy. But in the real world, you're going to separate things out, organize stuff. If you're sloppy all the time, it'll get you in trouble in the end. You can be sloppy with school examples, but, most people want things organized. So to emphasize the data encapsulation, let's take a look here. And we see a sample class first, and the sample class is body, the one that we've looked at in the previous examples. And the problem here is all the fields are exposed to be changed by everybody because we got public, public, public. And what I'm doing is just reviewing the public, private, protected thing. We'll see this in practice today when we work on assignment number 1. But and then we have our constructors. We have 2 constructors in here. But this is all exposed. So to emphasize the data encapsulation part of object orientation and improve it, we make it all private. So by default, you want to make all of your data private, and then you use your member functions to change the data. So the problem now is, but how can you access these fields? You can't. So you get accessors and modifiers. This is where those words come into place. So we've made these all private, and then we have our constructor that's going to set our ID, and this constructor here, this is the same constructor we saw before, but how do we change these guys now? Well, then we make 2 sets of methods for each one of the datas. One of them sets the data value, the other one gets the data value, and these are made public so that we can access them. So here we go. We can get ID, get name, get orbs. We can also have ones that set. So to improve the performance, these are called the accessor methods. I call them setters and getters. These are the get set because we're getting or accessing, accessor. So the method here, ID number, read only outside of the class. The methods that access the internal behavior are the accessors. So I run a get ID, a get name, get age. And we do this so we can protect this stuff. It's for a protective mechanism. So, and it's the common practice. And then here's the setters. So these are the getters to access. Sometimes they call the setters, accessors are the getters, and then the setters are the modifiers, or mutators, or I don't know, setters. Modifiers, the modification of the previous example here. Now we have the set. So set name, set orbs. So people like to put set name, get age, get age. And then put them in sets and separate them by a space, and then you can tell which one's which if you want. Your choice. Or you get all the gets and then all the sets. Your choice. Other languages do this for you automatically. Java does it. You have to actually explicitly write these methods yourself. And if you're in the Objective-C course, that's what this if you're in the Objective-C course, then this is what the property and synthesize does for you. It does the accessors and modifiers for you. You guys are, that's why I'm saying that. If you're not, don't worry about it. You'll get the concept later if you ever take Objective-C. And also don't forget that the private modifiers on the fields, when necessary, make them all private. The default access modifier on these fields is package level, actually, which is private to everything outside of the package. So let's not talk about virtual machines, but we have this thing called the class path. Actually, we can't talk about this. So to tell Java virtual machine, and I've mentioned the word class path a couple of times, this is all one word. It's like our path. So we set the path to make sure that the Java bin directory, the Java C command worked. We did this yesterday. We can also set another environment variable that goes into the same area in Windows, actually, called the class path. And it tells Java Virtual Machine where to find the .class files, just like the path for the environment variables. Class path is a collection of directories and archives that is a starting point for locating classes. When you install like JDBC drivers and stuff, it'll require you to set a class path, because then it won't be able to know, where is this package? Where is this? So first, suppose the following is in the current class path. We have this archive.jar file as an example. And then we can suppose that the interpreter is going to be searching through the class file. So it's looking for employee, let's say, for example. And if you search through the class in the system, they're stored in the archive here and here and here. It's going to find it in multiple areas. So you can set the class path to the version of the jar file that you're looking for. Same thing you did with the path for your Java install. So you can easily change which version of Java you're working with by changing the path, actually. And then you're going to get a different compiler version if you have multiple versions installed. So to set the class path, there's a command that you can do. You can do this on a Windows or into another environment, on a Mac as well. In fact, I could type this into my terminal window, and that would make it so my computer would compile my class files correctly. If you're using more than one class file in your project and you're using a terminal prompt, you need to set the class path in order to find all of the files that are part of that compilation. As you remember before, when I compiled, when I started to run it, I got an error message. The compiling worked because it was all in one directory, but when I ran it, the class path's not set, so it doesn't know where to find all this stuff. So again, don't worry about setting the class path. What's going to end up happening is you're going to get an error message like everything should work, but it's not running. And then you go online and look up how to set the class path, because it's going to be different for each one of your Windows versions and also different for Mac. So. Naming conventions. A little bit of notes. I've given you some hints already on the capital characters, capital letters of the first character of the names of classes or objects. We also have stuff for other things. As an example, package names start with lowercase letters. So as an example, when I was over here, I had to recall when I was starting to type in package, and I'm like, that's really lowercase. These guys are lowercase too. Everything's lowercase. So util.java, always lowercase. Class names start with an uppercase letter. All class names start there, even the ones you're making. So when we remember that today, when we start writing our first program, capital T in temperature. So and we'll follow that. I'll regurgitate that. Avoid name conflicts with packages. You don't want to call, you can do it, but you don't want to call your class the same name as the package. Because what are you talking about? You can easily confuse Java, essentially. And avoid name conflicts with standard keywords in the Java system. Everything's called string. Okay, great. Or class path. What? You know. Variable fields and method names start with lower cases. All your variables should have lower cases to them. Constant names should be all uppercase. So if I have pi, it's capital P, capital I. The whole word is in uppercase. If I have, I don't know, deviation or something, if I'm setting something, like I'm defining, well, pi is a better example, yeah. Multiple words. This is what I call the camel case. I don't call it, well, I'm probably mispronouncing it, but there's a name for it. So capitalize the first letter of the word after the first one. So here we have capital H because it's a class, capital W, capital A, capital N, and get name. And exceptions. So exception class names start with an uppercase letter and they end with the word exception. So we haven't looked at exceptions yet. This will happen during the second, kind of the intermediate stages here, where we have out of memory error, file not found exception. So this is a memory error, this is a found exception, so we could put the keyword exception in there. So supplemental reading if you're interested. Object-oriented programming concepts. Over here, these links actually still work. These are Java docs. Don't recommend that. From yesterday, the DDL and DDL text is what you're going to look at. So what we're going to do now is take a slight break, 5-minute break, bio break. And then, because this is a good time to take a break, because we're going to start coding the first assignment. So what I'm going to do in the coding the assignment is I'm going to try and go as slow as possible, so remind me if I go too fast. We're going to write the assignment from the description that we went over. We'll review the description briefly. And so what you want to do is make sure you got everything working on your system, and you're going to save what you're working on, because you're going to, if you're taking this course for credit, you're going to submit this at the end of this weekend. So one of your assignments is going to be practically written for you, and then that'll take us through probably like the lunch or so, and then we'll do inheritance after the lunch break or so. Questions before we take our first 10-minute break? All right, 10-minute bio break. Go get some coffee, gear up, so we can start doing some source code writing. And I'll see you in approximately 10 minutes.